All right, all you cool cats and kittens, here we are, Unit 1, Function Analysis, building functions from functions. I mean, this entire unit is all about what the heck can you do with the function? How can you talk about a function? How can you examine a function? So now what we want to focus on is taking 2, 3, 4 functions and somehow combining them together to create a new function, which sounds pretty cool if you ask me. So what do we mean when we say putting functions together? So first off, understand why this is important. Knowing how a function is put together is an extremely important first step when applying the tools of calculus. So again, I'm trying to teach you this to prepare you for calculus. Functions have their own algebra based on the operations we apply to real numbers. So think about addition, subtraction, multiplication, and division. The same operations that we apply to numbers, we could also apply to functions, right? And functions involve variables. So that's why we say that, functions really do have their own algebra that is based on the operations, the same operations that we apply to real numbers. So you already know how to build new numbers by using these operations. So what we want to talk about is how do you build a new function based on these operations? So before we get into building functions, let's actually start with building numbers. I know this is going to seem silly, but you have to understand that it's really truly no different. Like, we already know how to take numbers and apply operations to them. So like, you could use integers, like we know how to do -3 plus 5. And it doesn't take really anything to know how to do this. It's just, you guys already know, you get 2, right? Or we could do -3 times 5 and you get -15. Like, we already know how to apply these operations with numbers. Now, one thing that actually could be worth us going over is some of the ground rules for square roots. So square roots are a little bit trickier. For example, if we have the square root of 2 plus the square root of 3, you really can't do anything other than just the square root of 2 plus the square root of 3. There's nothing I can do with that. The square root of 2 is a number, okay? It's an irrational number, and so is the square root of 3. So I can't make that look any different. Some kids will say, oh, isn't that the square root of 5? No, absolutely not. The square root of 5 is a completely different number than the square root of 2 plus the square root of 3. But, another rule with working with square roots is if you're multiplying, well, make that as 3, then you are allowed to combine that into one square root instead of the square root of 6. So when you're working with square roots, there's some rules, and you got to know the rules, right? So the first rule is if you are taking a number times a number inside of a square root, you can separate them and give them each their own square root. But again, it does not work with addition and subtraction. The rule does not apply to addition or subtraction. A lot of kids have this belief that the square root of x plus y could be the square root of x plus the square root of y. That is not true. I hope you guys all know that, but that is one of the ground rules that you need to know when you work with square roots. Same thing with subtraction, right? If this was a minus sign, sorry, you can't separate. It doesn't work with addition or subtraction. It's just one of the ground rules when you're working with square roots. Now, division is kind of like multiplication. So if you have the square root of x divided by y, you could separate that as the square root of x divided by the square root of y. Okay, that makes sense. Now, again, continuing on with understanding square roots. Now, if the square roots are the same, like if you have the square root of 2 plus the square root of 2, well, that's like having 2 apples. If you have an apple plus another apple, guess what? You got 2 apples. So that would be 2 square root of 2. But I was only allowed to add those together because they were the same square root. But I also want you to note that it's not the square root of 4, right? I go back to this rule that is not a rule. You're not allowed to add the numbers and get the square root of 4, because I'm going to tell you right now, the square root of 4 is 2. The square root of 2 plus the square root of 2 is a very different number. It's, again, 2 radical 2. So hopefully that makes sense. And hopefully, I'm not teaching you anything brand new here, but sometimes, nobody forgets rules with integers. I mean, come on. You've been working with integers for so long, but square roots, maybe you haven't been working with that long. So sometimes you might forget some of the basic rules of what you can and what you cannot do with square roots. So, I kind of consider them like terms. Like the square root of 2 and the square root of 2 are like terms, so you're allowed to add them together and say that you have 2 square root of 2. Now let's talk about fractions, right? Like, what are the rules? What are the ground rules with fractions? Well, I hope everybody knows some of the ground rules with fractions is that if you're going to add or subtract fractions, you need to get a common denominator, right? So I have to write both of these with a denominator of 15. So I'm going to multiply the top and bottom by 5. 5/15 is equivalent to 1/3. And I could add, or I could subtract that to 6/15. Again, multiply top and bottom by 3. And now that I have a common denominator, I could either add them to get 11/15, or I could subtract them to get -1/15. It's just one of the ground rules. You got to have a common denominator in order to add or subtract fractions. But when it comes to multiplication or division, you do not need a common denominator. So if you're going to multiply, excuse me, sorry about that, then you just multiply. 1 times 2 is 2, 3 times 5 is 15. Just multiply straight across. Everybody, I guarantee, knows the division rule. If you're going to divide two fractions, well, that's the same as multiplying by the reciprocal. Sorry, I'm running myself out of room here. So I'm going to grab a different color so it stands out. So if you're dividing by a fraction, the first one stays the same, but you multiply by the reciprocal of the other, and then you multiply 5/6. So again, those are the ground rules, right? Integers I don't need to really go into much detail on, but know the ground rules for working with square roots and fractions, because here's the thing. When we work with functions now instead of numbers, those same ground rules apply. The ground rules don't change. All right, so let's talk about the operations with functions. So we can add, subtract, multiply, or divide functions just like we can numbers. And here is the notation for that. If I tell you f plus g, that means take function f and add it to function g. Now, when you add, you got to follow the ground rules, right? You got to make sure if they're fractions, you get common denominators. If they're integers, that should be easy. You got to make sure you only combine like terms, all those things. F minus g is f function f minus function g. Very simple rule. The only thing you got to be careful of here is that, you know, if g is many things, let's just say g is x squared minus 2x plus 3, when you subtract it, you got to carry that negative through it. Okay, that's another simple rule. Product multiplying f times g, or actually we just say fg, f times g. That means function f times function g. And again, you got to follow all the ground rules if you're going to multiply those. Quotient rule is f divided by g. That means function f divided by function g. So we got to make sure we follow the ground rules when we're working with fractions now. And one of those ground rules is that the denominator cannot be 0. So once again, if g was 0, then we'd have a major problem. So it says specifically g cannot be 0. So again, these operations are very familiar to us, but we just got to make sure we follow the ground rules just like we would follow the same rules when we're working with numbers. All right, so here is our first set of examples. So I got two functions. F is 2x plus 1. G is x squared plus 2x minus 1. And let's perform the following operations. Actually, on this page, I'm only going to have enough room to do the first two, and then I'll go to a second page for the next ones. So if I'm going to add these two functions together, let's go ahead and add them together. I'm just going to take function f. Some kids like to throw it in parentheses just to kind of keep it separated. I'm going to add function g. All right, now the ground rules say I just got to make sure I can only combine like terms. So there's an x squared, there's 4 x's, 2x positive, another 2x positive, and then -1 and +1 right here and right here are going to cancel out and make a 0. So there's my final answer. Beautiful. How about f minus g? So once again, I'm going to take f, 2x plus 1. I'm going to subtract, and this is what I was mentioning earlier. You got to be very careful with subtraction because I'm subtracting the whole function. So this negative would need to get ran through there. So that becomes 2x plus 1 minus x squared minus 2x plus 1. And when I combine these together, I get a negative x squared. 2x and negative 2x make 0x, so they cancel out. And then 1 and 1 makes 2. So there's my final answer if I subtract. All right, let's move on to the same problem. Oh, I just did those ones. Sorry. Here's addition, subtraction. We already did those. So sorry. Next slide. Here is the multiplication and division. So if I'm going to multiply, I'm going to take 2x plus 1. I'm going to multiply it by x squared plus 2x minus 1. And I got to follow the ground rules, right? Distribution. So I got to distribute the 2x, which gives me 2x cubed plus 4x squared minus 2x. And then I got to distribute the 1. And I get 1x squared, or positive x squared, plus 2x minus 1. And then I got to combine like terms. Again, following the ground rules. Sorry, I keep repeating that. So 2x cubed, let's see, my x squareds make 5x squared. My x's cancel out, the 2x and the negative 2x cancel out. And then I have the minus 1 on the ends. There's my final answer, 2x cubed plus 5x squared minus 1. All right, and let's do division now. So I take it, notice it says g divided by f. So I get g x squared plus 2x minus 1, all divided by f, which is 2x plus 1. Now, there's really not a whole lot you could do when you're dividing because the ground rules are a little bit more strict. There's a little bit actually less you could do. So I can only reduce factors from the top and the bottom. So on the bottom, I have a factor of 2x plus 1. The only way I could cancel that out is if I see the same factor above it. So one thing I could try to do real quick is try to factor the numerator. I don't believe, it might be factorable. Let's see here. I don't think so, because if I make them both negatives, then I'm going to get, that's not going to work actually. Yeah, that's not factorable. It seems like it might work, but one of them has to be positive in order to get a negative 1 in the back, and that's never going to get you a 2x in the middle. So that means it's unfactorable, so that really means there's nothing I could do here. I can't do anything. I'll get some kids that will try to cancel out these 2x's. No, right? You can't. You can't cancel out terms. It's one of the ground rules. You can only cancel out factors, and 2x plus 1 is a factor. I can only cancel out 2x plus 1 if I see the exact same 2x plus 1 above it as a factor. All right, here's two more examples that are just a little bit different functions. Now, I added a question here. So not only are we going to perform the operations, but we're also going to find the domain of the new function. Okay, so we're going to find the domain of the new function as well. And that's important to talk about, and I'll explain why here in a moment. So first, let's go ahead and add them together. So we get f, which is x squared, plus g, which is the square root of x plus 1. And again, remember the ground rules with square roots. You can't really do anything with them. So this is really all I got here, x squared plus the square root of x plus 1. Now, it does say find the domain. Now, I got to consider both functions. And remember, because there's a square root here, that means that the inside can only be greater than or equal to 0. That's one of our domain rules with square roots. So therefore, x can only be greater than or equal to negative 1. So that's my domain. It's starting at negative 1 and moving forward. So even though negative 5, there's no reason I can't plug negative 5 into f. Negative 5 squared is 25. But because I'm combining f and g together, no longer can negative 5 be used, because even though I'm allowed to plug it into x squared, I cannot plug it into the square root. And let's do the subtraction one, and honestly, it's not going to look a whole lot different. There it is, right? I can't really do anything different there. The ground rules of square roots, so you can't combine them unless you see another one exactly the same. So once again, my domain is going to be the exact same, negative 1 to infinity. All right, let's keep practicing here. Sorry, I have a new slide here. So let's do multiplication. So multiplying f times g would be taking f and multiplying it by g. And once again, I really can't do much there. There's really not a whole lot I could do here. But once again, I got to think about the domain, right? It goes back to the same idea. If for g, I got to be greater than negative 1, then the same thing is going to be true for this new function that was built with g. So since g went into this new function, I got to consider that that domain still applies as well. Dividing, f divided by g is going to be x squared divided by the square root of x plus 1. Now, our domain does change a little bit here, because now I'm not allowed to be negative 1, because if I plug negative 1 in, I get a 0. Now, zeros are okay in square roots, but it's not okay in a denominator. So because I created this denominator, my domain has a slight change to it now. And again, we've learned about all those things earlier. And lastly, they want us to do g times g. So that's going to be taking the square root of x plus 1 times the square root of x plus 1. Now, there's a ground rule, right? One of our ground rules with square roots is the square root of x times the square root of x is just x. As long as they're both identical, you essentially get the square root of x squared, but squares and square roots cancel each other out. So if you really want to get technical, this is the square root of x plus 1 squared, because you're allowed to combine them if you're multiplying. Well, the square and square root cancel, and you just get x plus 1. Now, this final answer right here does not appear to have any domain issues whatsoever. But because it was built from two functions, g and g, that do have a domain issue, even though this new function is simply x plus 1, the domain is still -1 to infinity because the original function g had that domain. So even though this new function is obviously different looking, it still was built from g. All right, so that is how you add, subtract, multiply, divide with functions. Again, as long as you follow the ground rules, you really can't mess up. All right, now let's talk about something new that's called composition of functions. So let's take a look at this function log of x squared. Okay, now it doesn't take a rocket scientist to see that it's somehow a combination of log of x and x squared. But this function was not put together by addition or subtraction, or multiplication or division for that matter. I didn't add them, I didn't multiply them, but it's clear that this function right here, that's a really ugly arrow, but it's clear that this function is somehow built from putting together log and x squared. But it's not put together by things that we're used to. Instead, it was almost like the first function was taking the second function and plugging into it. So the square function was put into the log function. So we actually have a name for this. It's not addition, it's not subtraction, it's not multiplication, it's not division. Those are different operations. This is a brand new operation called the composition. And composition is literally taking one function and plugging it into another function. Now, what's important to understand is that this new operation has no counterpart when working with real numbers. So if you're working with 2 and 3 and 5, just numbers, no variables, just numbers, there is nothing that is similar to this. This is only available when you're working with functions. So again, you're taking one function and plugging it into another function. So that's literally what I did on that previous problem, right? It was log of x squared. So what I had was I had log of x and I had x squared. And I literally took this function and plugged it into the other function. And that's exactly this notation. So the symbol we use is an open circle. But what that symbol means is take g of x, the second function listed, and plug it into f of x. So here's like a little picture diagram of this. And essentially what we're doing here is we're taking a number, x. We're taking a value, x, and we first plug it into g. Boop, 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 boop. G acts on that value. It does whatever it needs to that value, and you're going to get a new value, like the output. And then you're going to take that value and plug it into f, and that's the process. Okay, it's a very, very simple process. So let's kind of give you a quick example here. So if f of x is 2x plus 1, and g of x is 3x plus 7. So if I tell you, okay, what is f composed of g of 3? So what this tells me to do is I got to plug 3 into g. So that's 9. 3 times 3 is 9. 9 plus 7 is 16. So now when I plug 3 into g, I got 16. So that's the middle step, right? I'm sitting at 16. And now I'm going to plug 16 into f. So I'm now going to come back to f. Plug 16 into f. 2 times 16 is 32. 32 plus 1 is 33. So that is the end result. I'm taking a value, I'm inserting it into g, and then I'm inserting it into f. All right, so how can we do that with functions now? All right, so here's two more examples. F is x plus 2, g is 4 minus x squared. So I want to do three different things with this function. The first thing I want to do is I want to compose f of g. So g comes second, so I literally want to take g and plug it into f. So what does that look like? Well, think about it like this. F is this function that says take x, take something, and add 2 to it. So what I'm doing is the something is now g. So I'm literally creating f, composing it with g. So the something I'm going to plug into f is 4 minus x squared. So I literally took g and plugged it into x. I mean, hopefully that's very clear. Now I'm just going to clean this up. That's 4 minus x squared plus 2. The like terms are the 4 and the 2, so that is 6 minus x squared. All right, the second example wants me to do it opposite. It wants me to do G composed of F. So that means I'm going to start with G, which is 4 minus something squared. That's exactly what G is defined as, 4 minus something squared. And I'm going to literally take F and plug it into G. So the x plus 2 goes into G. So F, x plus 2, went into G. And then all I got to do is do some cleanup work, which is a little bit more here. The first thing I'm going to do is I'm going to take x plus 2 and square it, which is x squared plus 4x plus 4. Then I got to subtract, so I'm going to run that negative through it. Minus x squared minus 4x minus 4. Then I'm going to combine like terms, negative x squared minus 4x. And then the 4 and the negative 4 are going to cancel out. And my final answer there is negative x squared minus 4x. All right, now this last one deals with a number, right? So again, I got to do what I just kind of taught you earlier, is I'm going to take negative 2. It's going to go into f first. So if I take negative 2 and plug it into f, I get 0. So once plugging into f, I get 0. That's like the middle step. Now I'm going to take that 0 and plug it into g. 4 minus 0 squared is 4. 4 minus 0 is 4. Now the other option you could do is to take negative 2 and plug it into the function we created, that is f of g. So if you take negative 2 and you plug it in here, negative 2 squared is 4. You're going to get a negative 4 because that negative is sitting out in front. Negative 4 times 4, excuse me, negative 4 times negative, I'm messing this up. So let me slow down for a second, I'm sorry. Again, plug negative 2 in, you get negative 2 squared, which is 4. Then there's a negative out in front, so it's negative 4. Negative 4 times negative 2 is positive 8. Negative 4 plus 8 is positive 4. So either way, following it step by step, going into f first, then g, I still get an answer of 4. Or I could plug it into the new function I created, that is f composed of g. All right, since this is new, let's take a look at another example here just to make sure we're going nice and slow. So a second example here is two new functions. F is x squared minus 9. G is the square root of 9 minus x squared. And we want to first find f composed of g. So once again, my thought process is I'm starting with f. F is x squared minus 9. Something squared minus 9. But what I want to do is plug g into f. So I'm literally going to take g, square root of 9 minus x squared, and plug it into f. Now here's what something cool happens. When I clean this up, it's going to be awesome. The square and the square root cancel. That is amazing. Then the 9 minus 9 makes 0. So I get negative x squared. Really nice and simple. But it also wants us to think about the domain here. And that's because the final answer doesn't look like it has any domain issues. In fact, this final answer, you could plug anything you want into it. But since it was built from a function that did have a domain issue, I do have to consider the fact that there are some values that aren't going to be allowed to be used here. So I got to go back and think about g. The inside of the square root has to be greater than or equal to 0. Now to solve this, I'm going to factor 3 minus x times 3 plus x. We did a whole unit in the prerequisite unit on, or whole topic on solving quadratic inequalities. So I get two answers, x equals 3 or x equals negative 3. So I'm going to put those numbers on my number line here. And let's see here. Numbers below negative 3, if plugged in, are going to create, let's see here, a negative and a positive. So for example, if you type negative 20, 3 minus negative 20 is a positive, but 3 plus negative 20 is a negative. So sorry, positive and a negative. But regardless, numbers below negative 3 are going to be negative. In between negative 3 and 3, pick a number like 0. 3 minus 0 is positive. 3 plus 0 is positive. Those numbers are also going to be positive. Any number above 3 is going to produce a negative. If you don't believe me, just pick a number like 20. 3 minus 20 is negative. 3 plus 20 is positive, but a negative times a positive is a negative. So the only numbers that are greater than or equal to 0 are negative 3 to 3. So my domain of g was limited because it got that square root, which means the domain of my composition is also going to be negative 3 to 3. Even though it doesn't look like it has any domain issues, because it was built from a function that did, I got to consider the fact that it did have those domain issues. All right, so here's the final slide here. This is the final thing that we could ask you to do, is sometimes I might give you a function and say, hey, can you create two functions that built this function? So it's essentially working backwards. So if you look at this function, h of x, and I want to say, hey, can you define two functions that would allow me to create this new function? And I want to think, all right, what can I plug in, right? So I tried to make it pretty obvious, at least I hope I did. So if g is x minus 1 and f is x squared minus 3x plus 4, composing f of g would create this function. So if I took g and plugged it in to x, I would get this function, x minus 1 squared minus 3 times x minus 1 plus 4. So again, you have to kind of look at it and think, all right, how could I create two functions that would build this one function? This next one, working with square roots, is actually fairly easy. So if f of x is the square root of x and g of x is x cubed plus 1, I literally could take g and plug it into f, and I would get this new function. So my two functions would be the square root of x and x cubed plus 1. All right, how about this bottom one? Well, once again, I'm trying to make it obvious, but it may take a couple of examples for you to see it. If I allow the overall function to be 1 over x squared, and then g is x minus 2, that would create h of x. You would literally take x minus 2 and plug it into f, which would create 1 over x minus 2 squared. So I'm not going to go too crazy with these types of examples, but you should be able to understand how one function is built from two other functions based on kind of visually looking at it. All right, so hopefully that all made sense to you guys and that there weren't too many problems here. Again, really in this video, we just talked about addition, subtraction, multiplication, division, and you should already know how to do those things. Just make sure you follow the ground rules, right? I got to make sure I get ground rules in one more time. And then again, composing functions is brand new, and it only works with functions. You cannot compose numbers. It only works with functions. You can compose two functions of each other. Just make sure you do think about domain, because anytime you put two functions together, you got to consider the domain of where those functions came from. All right, guys, that's it for this video. Building functions from functions, taking multiple functions and putting them together somehow, some way.